The natural world is full of colours that we often take for granted. There are few animals more brilliantly coloured than these scarlet macaws. Animals can use colour for all kinds of different reasons, and some have colours that we ourselves can't even see. But not all colours are what they seem. Some animals also use colours to hide. Colours that make them disappear. Colours that create optical illusions. And colours that are used to trick and deceive. To understand how these colours work, we need to see them from an animal's perspective. With the help of our specialists, and discover how some animals have become masters of disguise. The Indian subcontinent is home to some truly spectacular animals. Most, like these peafowl, use colour to attract attention, and the kinds they've developed are influenced by the way they see the world. But flashy colours can also come at a cost. And sometimes it's better to remain out of sight. So some animals use their colours to help them hide and disappear into the background. One such animal lives here, in the forests of central India. It's one of the most formidable hunters on Earth. A Bengal tiger, a female. She's one of the world's biggest cats, and remaining out of sight is not easy when you are as large as she is. Her orange and black coat is crucial to her success. To have any chance of catching a meal, she has to get to within a few meters of her prey. She keeps to the cover of the trees and slowly makes her approach. She may appear conspicuous to our eyes, but not so to these chital deer. Down by the water, she finds one, sambar deer. Sambar don't keep company with monkeys. They are on their own. They have the same limited eyesight as the chital, but ears like satellite dishes. If she treads on a twig and it snaps, the hunt will be over before it began. The deer seem to sense danger. They still can't see her. Less than 10% of her attacks are successful. But without her orange fur, her chances would be even lower. It is her colours that are key to her survival. The Cairngorm Mountains in Scotland. Here there are special problems for the hunted. Some animals have developed camouflage of such perfection that they are virtually invisible against their surroundings. But what happens when those surroundings change? Well, then, of course, the animals have to change too. These mountains are home to a particular kind of grouse called the ptarmigan. Their mottled brown feathers make them inconspicuous among the rocks and heather. But in winter, these mountains are hard places in which to live. Temperatures drop, and the land can overnight be covered by a blanket of snow. Most birds by now have gone south to warmer parts of the world, but not the ptarmigan. When winter comes, they undergo the most extraordinary change. They replace their brown feathers with pure white ones. They do so for a simple reason. They must go unnoticed. They need to hide. This open habitat makes the ptarmigan very vulnerable to predators. Being the right colour is crucial. Now they are invisible even to a keen-eyed eagle. Ptarmigan are not the only animals to use this disappearing act. So does the Arctic fox, snowshoe hares, and weasels. All, with the coming of winter, change their coats and vanish from sight. Their transformation is triggered by the decreasing daylight, and over several weeks, they replace their brown costumes with white ones. So, changing colour with the seasons, for some animals, is the only way to avoid becoming a meal. But many plants, of course, do the reverse. In spring, they produce colour to declare that they're providing food, nectar. Bees and many other insects love it. In spring and summer, they travel busily from flower to flower, collecting it. And when the bees leave to look for more, they inadvertently take pollen with them, which then fertilizes the next flowers they visit. But there's a hunter here that exploits this relationship. A crab spider. She's tiny, no bigger than a fingernail, and she's waiting for her prey. Almost the same colour as her background. She's virtually invisible. No more honey for her. But of course, the spider's hunting grounds are limited. Not all flowers are yellow. When she sits on a pure white petal, she immediately becomes obvious. She will never catch a bee while she's so conspicuous. So she changes. She breaks down the yellow pigments in the outer layer of her skin to expose special crystals underneath that act like tiny mirrors and reflect the light. It may take a few days, but she turns from yellow to white. Changing colour isn't the spider's only trick. There's more to this story than meets the eye. Bees can see colours that we cannot. They can see ultraviolet colours. As they come in to land on the flower, they use special sensors that can detect ultraviolet patterns on the flower's petals. There are dark lines on the petals that mark the landing strips for the bees, guiding them to the nectar. The spider, however, has developed a way to exploit these signals. Watching her with our UV camera, we can see that she reflects ultraviolet light, so she appears even more conspicuous sitting on a flower. This extra brilliance acts as a kind of super signal which the bee can't resist. And the spider benefits. In fact, the bees are more than 3 times as likely to visit flowers with UV reflecting spiders on them than those without. The crab spider uses a sophisticated range of colours to deceive its prey. But colour can also be used in a simpler, even more surprising way to confuse the enemy. And on the plains of Kenya's Masai Mara, there's one animal that uses just 2 colours to outwit its predators. The zebra. Its black and white coat makes it extremely obvious as it grazes out on the open grasslands. Other grazers have softer, gently varied coloration which blends with their background. So it seems strange that zebras apparently do quite the opposite. Particularly as they live in a world where there are so many hunters. Lions, hyenas, and cheetah. The boldly striped zebra seemed to be asking for trouble. How do they get away with it? The question has been hotly debated by naturalists for centuries. New research is now suggesting an answer. To understand how it might work, we need to consider the particular colours involved. Black and white are two of the most contrasting colours, and no two animals have exactly the same pattern, so each has a unique whole-body fingerprint. But when the zebras move, the stripes create confusion. It's known as motion dazzle, and it makes it difficult for a predator to keep focused on one particular target. The cheetah are looking for a meal. To make a successful strike, they must judge the distance accurately and time it perfectly. So if a zebra's stripes can confuse a cheetah just for a few crucial seconds, it may escape. But there's another threat on these plains. Flies. They are a real pest here. They're not just a nuisance, they carry diseases, some of which are particularly nasty, even deadly. Despite the huge numbers of flies, the zebras appear remarkably untroubled by them. There are plenty of flies around, but few actually land on the zebra. One theory is that the black and white stripes make it difficult for flies to judge the distance. To test this idea, scientists counted how many flies landed on animals with gently graded colours and how many landed on the zebra's stripes. They found that 4 times fewer flies landed on zebras than on their more plainly coloured neighbours. Why should that be? It seems it's another consequence of those stripes. They confuse the flies as they make their final approach to settle. Perhaps this creates a visual blurring for the flies, much as it does for a cheetah. So it seems that the zebra's patterns of stripes creates an optical effect that helps protect them from enemies both large and small. While zebras use different patterns to confuse their enemies, on the island of Cuba, there are smaller and rather slower-moving creatures that do a similar thing. This is Polymita picta, a Cuban painted snail. You might think that this one is an exceptionally lovely, eye-catching individual. But it's not by any means the only snail that is so beautifully decorated. No two individuals are exactly the same, yet all these belong to the same species. There are also 5 other species of Polymita here. Each snail has its own unique combination of colours and stripes. Their colours come from their diet. Lichen and mosses rich in minerals that give the shells these stunning colours. They differ according to the particular mix of plants that each snail has been eating. Variations of individuals within a species is not uncommon in the natural world. It's called polymorphism. But it's particularly marked among Cuban snails. Some scientists believe that the variation in itself may be a kind of defense against predators. But how could that work? Most animals looking for prey have a search image in their minds. They scan their surroundings looking for a victim that matches their expectations. If they see something they recognize, they'll go for it. And that's where the snail's varying colours may come in. The great range of different tints and patterns, it seems, confuses the birds. He's never seen one quite like this before. And while the bird is wondering whether it's edible or not, the snail can slowly make a getaway. So it seems that colour can both conceal and confuse. And sometimes it's used in yet a third, quite different way. Some poisonous animals, like this little ladybird, use colour as a warning. It's bright red, and that's a message which says, keep away, I'm poisonous. Red, black and yellow are widely understood as warnings. So the ladybird's message is a truthful one. It is poisonous. But some animals that are in fact harmless have found it profitable to develop these warning colours themselves. This African queen butterfly, like the ladybird, is indeed very poisonous. But this is a different species entirely, a Danaid butterfly. It has almost exactly the same coloration, yet it's perfectly edible. It is, you might say, using its colours and patterns to tell a lie. To our eyes, And to that of the predators, poisonous and non-poisonous individuals look almost identical. And that's the point. The Danaid mimics the colours and patterns of the African queen, and so it isn't eaten. Mimicry like this occurs quite frequently among insects. Animals which use mimicry for a rather more sinister purpose. And one such creature lives here on Australia's Great Barrier Reef. Just beneath the surface, the reef is a riot of colour. But that means there are great opportunities for deceptions. A blue-striped blenny. It lives close to a cleaning station, a place on the reef where large fish come to get their parasites picked off by smaller fish that feed on what they remove. This little wrasse is one of these cleaners. It has a long-standing relationship that relies on trust. The big fish get a health treatment and the little fish get a meal. But the blenny has learnt how to exploit this trusting relationship. It leaves its hole and starts looking for a meal. But the big fish don't seem to trust it. It's time for a change of costume. Filmed close up, under controlled conditions, we can see how the blenny's brown stripes turn black. The pigment cells in its skin expand and contract to bring about this subtle change. But it's enough to do the trick. The blenny now looks very similar to a juvenile cleaner wrasse. It's a devious disguise, and one that will help it take advantage of the arrangement the cleaner wrasse has developed with its clients. It spotted a target, a butterfly fish. The blenny hangs back, allowing an established cleaner wrasse to start work. Now the blenny slowly moves in, as if to offer the same service as the wrasse. But once within range, it strikes. Its razor-sharp teeth have removed not just dead skin, but a chunk of flesh. This isn't the treatment the butterfly fish was expecting. The blenny's deceit may work for a time, but eventually it has consequences. Reef fish begin to associate the distinctive colours of a cleaner wrasse with the pain of the bites of a blenny. Then they will eventually stop coming to this cleaning station. And that is bad for business for the blenny too. So it's time to let things cool off. A quick change back to brown, and its deception is over, for now. All the while, it keeps its eye on the cleaning station and waits for its next target. Some animals change colour for short periods of time in order to deceive others, but some use colour mimicry permanently as a method of persuading a different species to rear their young. One such creature lives here on the grasslands of southern Zambia. A nest hidden in the grass. It belongs to a pair of common waxbills. They are busy feeding their chicks. The hungry youngsters open their beaks to display a conspicuously patterned gape, which says, in effect, "Food here, please." And the parent obeys. But among them, in this nest, there is an imposter. One is significantly bigger than the rest. It hatched from an egg that was surreptitiously laid in the waxbill's nest by a pin-tailed wider. Having done so, she flew away, leaving her young to be cared for by the waxbills. But why do the waxbills feed this imposter? The parent birds recognize their young by the pattern of their gapes. And the black and white markings are characteristic of their species. But the imposter's markings closely mimic those of its nest mates. And because it's bigger, it takes nearly all the food, and the young waxbills get little or none. Two weeks later, and the young wider is much bigger. By now, however, the adult waxbills have accepted the young wider as their own, and the more it begs, the more they give it. One last meal from its luckless foster parents. And the young wider leaves its nestmates behind. And this is what it will grow up to be. Quite different from the hard-working waxbills that raised it. All pin-tailed widers are reared like this. Mimicry wins. Deceiving a different species is one thing, But in South Africa, one animal uses mimicry to fool its own kind. The Orange River, the largest in South Africa, and on it, the Augrabes Falls. These are the main home of a particular species of flat-backed lizards. The males are brilliantly coloured. The females, on the other hand, are very different. They are plain and drab. The brilliance of a male's colours is an indication of its physical fitness and strength. The higher their status, the more colourful they are. And they're not afraid to make their seniority quite clear. A side shuffle dance showing off their colours is usually quite enough to settle who is the boss. But if that doesn't work, they fight. Their disputes are all about location. Sometimes they want a vantage point from which to show off. At others, a good place to hide. Or to get close to the river, where there's food. Here on these falls, food means flies. The river is a breeding ground for black flies. There are huge swarms of them. And they are the favourite food of the lizards. They have acrobatic skills needed to catch them. While the colourful males are busy feeding, a different kind of male appears. He is brown, rather like a female. There's just a hint of blue on his throat that gives him away as a male. He's fully mature, but not yet strong enough to compete with his flashier neighbours. To avoid fighting, he delays the development of his colours and so mimics a female. 1 in 10 young males behave in this way. But he still needs to eat, and to do that, he's got to get down to the river where the flies are. That means getting past the powerful, highly coloured males. One thing could reveal the deception. He may look like a female, but he smells like a male. As long as he keeps his distance, he'll be all right. The big male hasn't noticed that he's not a female. Almost there.
Only one male now stands in his way. The most dominant and aggressive of the lot. He's made it. His disguise worked, and now he can feast on the flies. He won't be able to keep this up forever. Ultimately, all males have to put on their glad rags and develop those bright colours if they are to breed. For now, though, he's developed a disguise that enables him to cheat in one of nature's most colour-dependent mating systems. So, animals of all kinds use colour in a multitude of different ways. New discoveries, these animals, and new cameras are allowing us to see into a world of
We're only just beginning to understand the many different ways in which animals use colour, particularly those colours that we can't even see. For us, colour in the natural world is a source of beauty and wonder. But for animals, it's a tool for survival.
It's not paint by numbers. The Life in Colour book is available now and will make your world unimaginably brighter. And Chris Packham's Animal Einsteins looks now at the great architects of the animal world. That's over on BBC 2. Here on BBC 1, Antiques Roadshow's next.